Welcome fellow chemists to the second of many videos on the reactions of the alkenes. This particular video will cover the addition of water, which is also known as hydration. Pay close attention to this one because there are many similarities that carry over into the next video. First, let's take any old alkene and react it with water. No, nothing is wrong with your screen. Nothing happens if you take an alkene and add water. In the previous reaction of the hydrogen halides, the natural acidity of those halides make them reactive enough on their own. Water, however, is not as acidic, so it needs a bit of a boost or else nothing happens. So increasing the acidity is just what this reaction needs to proceed. Then it is literally the addition of a water molecule onto the carbons of the double bond. Piece of cake. There are countless reactions in organic chemistry, and trying to memorize them all is quite difficult. Luckily for us, we have more or less already seen much of this mechanism. First, a bit of a step back to your general chemistry days. The first step is the formation of hydronium ions. This happens when water is in the presence of an acid. We will now have electrophilic hydrogen just like we did with the hydrogen halides. It is the hydronium ion which is our catalyst. One of the hydrogens from the H3O+ will add to the double bond. As we already know, the tendency is to form a tertiary carbocation if possible, if not secondary. In this case, we create a secondary carbocation, which is the most stable possible. Now that we have generated our carbocation, what's next? Now comes the addition of the nucleophile, where before it was the halide that had electrons to spare, now it is the oxygen of the water molecule that does. The pair of electrons on the oxygen is used to form a bond with the carbocation. What looks like a weird hydroalkane is actually a protonated alcohol. This won't stick around because a molecule of water will remove the hydrogen from the protonated alcohol and regenerate H3O+. Remember, this process is acid-catalyzed, so we need to regenerate our catalyst, H3O+, by the end of the mechanism. And of course, the other product is the alcohol. With a rather simple mechanism behind us, we can take a look at the regioselectivity of this process. In the following examples, there will be two potential products generated by the reaction of the alkene and water. For the reaction of propene, the products are either propane-2-ol or propane-1-ol. Hopefully you have already recognized that the propane-2-ol on the top is secondary and the propane-1-ol on the bottom is primary. We would expect the major product to be the secondary propane-2-ol. Next up, we have 2-methylprop-1-ene, and the potential products here are either a primary or a tertiary alcohol. With your ever-increasing knowledge, I'm sure you can pick out the tertiary product quite easily. And of course, we would expect this one to be the major product of the reaction. Finally, we have 2-methylbut-2-ene, and a glance at the structure informs us that we can either generate a secondary or a tertiary alcohol as a product. As we expect to produce a tertiary product most often if possible, the tertiary 2-methylbutan-2-ol on the top would be the major product of this reaction. So in summary, the addition of water is literally the addition of water across the double bond. It only proceeds in the presence of an acid. The acid promotes the formation of H3O+, which supplies the electrophilic hydrogen. This hydrogen then adds to the sp2 carbon with the greater number of hydrogens. The carbocation is an electrophile and the water molecule a nucleophile. A pair of electrons from the oxygen on water forms a new bond with the carbocation. At this stage, we have a protonated alcohol as an intermediate. A new water molecule removes the additional proton, which reforms the H3O+ catalyst. The product is an alcohol, and we would expect a distribution favoring tertiary if possible, or secondary. In the next video, we will discuss the addition of an alcohol. Thank you very much for watching. If you enjoyed this video, please like and subscribe as I have more in development. As we know how to form alcohols from a reaction now, you might want to freshen up on naming these molecules if you have not already. As usual, feel free to get in touch with me via email, social media, or if you would like, make a request in the comments.